So thanks for coming. I know it's always the last day of the conference, and it's not easy with all the presentations. Anyways, so bit about me. My name is Klaus Kempf. I'm the product owner and technical lead for SUSE Manager. And this is something I'm working on since a couple of months now. We use it for SUSE Manager, but it also might be useful for you. And yeah, let's get started. You might wonder about the title. So ELK, and there's a bit of confusion because for some people this is an ELK. But for European people, this is a Wapiti. This is also the biological name. And this, for the European people, is an ELK. And for your Americans, is a moose. So, but just to clear the confusion, let's see. We will find a third definition for ELK in a moment. Just a preface. So, as I said, this is something I'm working on in the SUSE Manager context. And yeah, that might result in a product later if there is sufficient interest. I'm quite confident that this is useful, but you have to find out yourself. So let's see, what do we have? What is the problem statement we are talking about? Log management and log analysis. So every tool you have, every service writes log messages, sometimes lots of them. What do you do with them? Maybe you collect them somewhere and then they're sitting around. And we in engineering, we have also the problem. What we always see is something like this. And those of you who have already reported a bug against one of our products might have been asked to upload a support config. And the support config also contains all the logs, and we engineers now have to find the needle in the haystack here. Okay, what is going on, especially if there are multiple logs involved for multiple services. So typical example for SUSE Manager. SUSE Manager has an Apache web server where the request comes in, and then it has a Tomcat Java application, and it has a WSGI Python stack. So and depending on which URL is requested, either goes there or there. Then Tomcat writes its own log, the Java application writes its own log, the Python stack writes its own log, and now you need to make the connection. Okay, there's a request coming in, and it goes here, and okay, there's the error trigger. What you actually want is something like this. That would be cool. And yeah. I personally haven't figured out how to create a dashboard like this yet, but we are getting there step by step. So it is possible. With the tools I present today, something like this is possible. So now the third definition for ELK. So actually 3 tools. The first called Elasticsearch, second one Logstash, and the third one Kibana. So what is Elasticsearch? The company behind it is called Elastic, and these tools are open source, which is quite wonderful. And they build a stack for log management, central collection of logs, and then log analysis. So how do they relate to each other? This is a kind of stack. So it starts here on the left with various tools creating log messages. So on top here, for example, you have Apache. This is the symbol for Tomcat. And this is log4j. This is a typical log library for Java applications. So SUSE Manager, for example, uses log4j to write out log files. What you can do now is tell all of them to actually send their logs to Logstash, which you can configure to have open ports. It can run either on the same machine or even better on a second machine, which then kind of reads from the fire hose and stores the logs into Elasticsearch. Elasticsearch is a database. It's a full text database. I will tell a bit more about in a moment. And then Kibana, again, attaches to the database and queries the database and then analyzes, makes statistics or nice graphs. And the nice thing about this is not limited to log files. Elasticsearch, you can put anything in here as long as it's somehow structured, and then you can use Kibana to dig through the structure. Okay, a bit of details about Elasticsearch. So Elasticsearch is a full text database. It's actually based on an Apache project which is focused on full text analysis. So you can have complete book and it analyzes through this, breaks it down into separate words and so on, and then you can make queries on top of this. It is highly scalable and it's very easily scalable. You just spawn more processes on different machines and they can find themselves. So it's like this, very nice. Bit of a bad side is the terminology, because if you come from a database background where you talk about database and schema and records, Elasticsearch has a bit different terminology. So a database in Elasticsearch is an index. A schema is a so-called mapping. And a record, so a single line in a table for a typical SQL is a document. And then the columns are fields, and that's basically key value pair. The nice thing about Elasticsearch is that it actually schema-less. So you can put whatever key value pairs you have into this. This interface is JSON, so you can just write stuff into this and analyze it with Kibana. However, it is recommended, and I learned it the hard way because it was slowing down, that you actually create a schema and say, okay, this is actually a numeric value. And this is a string, but I don't want you to break it into single words. Please keep it as a string because I want to search for the string or not for single words inside the string. Typical example would be error messages. Doesn't make sense to break them into separate words, but you want to see the error message. So this is an example for the raw data that is stored in Elasticsearch. This is just how it looks like. So this is always, this is the key and then the value, key, value, and so on. But if you look closer, you will find out that they have different prefixes. So some have an ampersand, and others have an underline. And this is how Kibana finds out what to look for. And what is important to note is Kibana is actually based on time-based events. This is the default for Kibana, and this is why, for example, timestamp here has this ampersand in front. This is what Kibana looks for. Yeah. Now Logstash. Logstash, as I said, is a tool which reads all the log from various sources. So it's a log server. Also highly scalable. Same way like Elasticsearch. Also here in Logstash, focus on time-based events because this is the main use case. Log files, they have all usually start with a timestamp, and this is also what you're searching for in most cases if you do log analysis. So it has special code and libraries to detect timestamps, and it knows, okay, this now I need to translate to ampersand timestamp into Elasticsearch. The code, interestingly enough, is written in Ruby and runs in JRuby. JRuby is a Ruby implementation for the Java virtual machine. And the usual word is saying, oh, Ruby is slow, don't use Ruby. I mean, getting all the logs in, analyzing them, splitting them into fields for Elasticsearch is a lot of work, and Logstash is capable of this. That's quite a surprise. So, it has three main components. The one is an input definition. It says, okay, open these ports and expect this type of input there. Then it's a filter, and the filter is actually a regular expression parser. So it gets a complete log line, and then you parse out the timestamp. And then a client information. For Apache access log, for example, the last field is typically the HTTP return code, which typically for a good web request is 200. And if it's bad, there's a 500. So these are the things you are looking for. And then there's an output definition, which, okay, typically it's Elasticsearch, but it could be something different. So highly, highly flexible and fast. Okay, let's look at a typical input configuration. And the problem with Logstash is getting these regular expressions right to analyze the log files. So this is a good start to say, hey, Logstash, just read from standard in, and you just cut and paste log lines there to get your patterns right. This is the most simple input you can have. A more complex input would look like this. So this says, open a TCP, port 9000, and whatever comes there, give it a type named access log. And this would be typically an Apache configuration where you say, okay, Apache, write your logs, your access log file to this Logstash server at port 9000. Because then it's much easier, then you know, okay, on this input port, I already know what to expect. If you would write all the logs from Apache and Tomcat and other Java stacks to one, you have a while to mix, and your pattern matching would explode. So this is how you can partition it. What you can also do is you can add tags here. So kind of markers, which you later can either use in your regular expressions, or even in Kibana you can search for these tags. And then you need the filter. And this is really the part of Logstash where you have the log line, which comes in as a big string, and you try to break it down into reasonable parts that you are interested in. So the filter configuration is usually one big configuration for Logstash. But in the previous example, for example, we had access log and error log listening on different ports, so I already partitioned it. And here in the filter conf, I use this partitioning in this if statement. I say, okay, if the log message that's currently coming in is of type, here I use author dispatcher, and this type is this type here, which I attached here. Then try to grok. This is, everybody knows what grok is? I guess yes, to understand. And a match. And the message looks like this. Oh, pretty ugly. This is actually the regular expression just for the timestamp. And log lines can get very long and have multiple patterns. So you can imagine such a regex will get pretty ugly pretty soon. And it's a mess to debug this. But luckily enough, there's something in Logstash which helps you with that. And this is pattern definitions. So you can give larger regular expressions a name. And this I do here. So this is a typical line from author dispatcher. It has a date, a time zone, a PID, an IP address, the part of author that was creating the log, and then the type of message and the actual message. And here I now say, okay, this is the expression for the timestamp. And then I have a PID. So PID is just a decimal and many of those. Then this is a function definition. So this is a word character, an underline, or a dot, many of those. And this is the argument. The argument start with a parenthesis, and then there's everything which is not a parenthesis and a closing parenthesis. That's just a couple of examples. And then your filter conf looks like this. And this is much more readable. And what I did here is also I say, okay, this is the pattern. This is the field name. And I attach a type here, because the PID is typically an integer or numeric value, and so on. There are many predefined patterns you can use, so it is actually not that hard. But getting the patterns right and getting to debug this, it takes time. It's not that easy. Okay, and what else do we have? The output filter. And here, again, this is this most simple output filter. It writes to standard out in a structured way. And then you can see what parts of the message the filter grokked and which were not grokked. And then you know, okay, I need to adapt my pattern here, or my filter configuration. So in this way, it's very simple to get this filter pattern right. Or you say, okay, Logstash write to Elasticsearch, and yeah, here on localhost, this is a typical port. But as you can see here, it's hosts. So you can already here say, okay, write to multiple Elasticsearch databases. Yeah, very simple and very nice. So the point is you have a couple of .conf files, the input, the filter, and the output, and you have a couple of .pattern files. And what worked quite well for me was to put them all in one directory. So I have filter conf here, input conf, I have pattern here, I have here a pattern file, and I have another conf file. And I run Logstash like this. I say -f, these are the filter definitions, is anything in the current directory which ends in .conf. If you would just say asterisk here, then it would read the pattern file and try to pass it as a filter, and I can't. And also for debugging, -- auto reload. So I can test it, and I can edit the pattern or the config file, and I don't need to restart Logstash, which takes a while to start up. And this way, it's quite easy or straightforward to get all this configuration right. Questions so far? Okay. Let's see. Kibana. Kibana is the graphical front end to Elasticsearch, which allows you to now analyze whatever is in Elasticsearch. It's a visualization front end, web, you start it in your browser. The main focus, as I said before, is time-based events. So it looks for this @timestamp field. And this is also, the UI is structured this way, and we will see it in a moment. I will give you a short demo. In Kibana, there are 4 tabs you have to go through. The one is settings, where you say, okay, these are the Elasticsearch indexes, the databases I'm interested in. And it can be multiple. So Kibana can read from multiple Elasticsearch indexes and aggregate all this. This is quite nice, especially when you spread out your logs. You could have daily logs, per index, and after 3 months you start to delete all the logs. But Kibana can aggregate. Then discover, where you then see, okay, these are the fields which are in my aggregation, and you can see the values. You can see, okay, these are the things I'm interested in, and basically queries, and you can store them and retrieve them later. Then there's visualize, where you can have a wide range of visualization patterns. Pie chart, a bar chart, a line graph, whatever makes sense. You can also combine them. You can have stacked graphs and so on. In the initial example, you had also a world map. So in the log could be geographical coordinates then you could visualize these events in a map. And again, these visualizations can be stored away and retrieved later. And then you have the dashboard. And the dashboard is initially empty, and then you can, based on your saved visualizations, pick those visualizations and assemble your dashboard as you want. And then once you have this dashboard assembly, you can also store it, create the next one, retrieve the old one. So quite nice. Yeah. I guess it's time for a demo now. Yeah, I'm an old man. I need glasses. Let's see. So, oh, I should. Arrange. Oops. Let's see if this works. No. Okay, it doesn't work as thought. Then I show you my web browser. So this is actually has nothing to do with Kibana. This is a log, an ELK, Elasticsearch front end. And what I have here is from SUSE Manager 28 million log entries. This is from our development server, so quite some. And Kibana, when I started, will look like this. Oh, no records found. So what I need is go to settings, and here I can say what Elasticsearch databases or indexes I am interested in. So the default is index contains time-based events, and it says Logstash asterisk. But what I'm actually interested in is the manager one. And then it shows me here all the fields it found, the types, and so on. And here's this analyzed field. The analyzed field says, okay, when there's a string, break it down into separate words. And this takes a lot of time and is not useful for error messages. So this is why all the strings are non-analyzed. It's quite important. And you can, for example, if you add other records to this which have new fields, you can just reload it, and Elasticsearch will reconfigure itself. So discover, you start with this, because the default is last 15 minutes. And I mean, the logs are a bit older. So here I can choose the time range, for example, last 2 years. And then it searched through 28 million records, and it's done. So it's pretty impressive. And as we can see here, okay, in 2015 we had quite some log entries. As I said, this is the logs from our development manager. So it's development SUSE manager. So it's not in constant production, but as we try out things, there are peaks. And here you see the raw data. I've shown this in the previous slides. And here are all the fields. And let's see. Yeah, so what I can do here, for example, is go to the type field and just do an analysis on the type field. And this is just by clicking on the type field. So I already know here, okay, 32% of the 28 million are coming from OSA dispatcher. There are 28% coming from RHN Web API and so on. This is true for every field. So you can here do an initial analysis. For example, another good example is error message. So you see here what type of error messages are there and the distribution. And here now you could choose key value pairs and create queries. So, and next is visualize. And this is, for example, the distribution of the log lines I have. So this is the access log, OSA dispatcher, error log. We still have some Apache errors, but luckily not all the Apache accesses were errors, so on. And if I go here, I create a new visualization, and here you see all the different visualization types, so tile map, pie chart, metric, line chart, data table, and so on. And then there's a dashboard. And when you create a new dashboard, that looks like this. And I guess it's this. No, that's a link. Yeah. I can open the dashboards here, and I load this. Yeah, and I can here resize it and create my dashboard as I want. So this, for example, is the error messages, and I see, okay, I have quite many coming from Apache, and here is from mod Python, which actually is not an error message. So I could filter this out and make this more useful. But this is really a nice playground, so to say, to dig deeper. And you can save all of the steps and retrieve them later. Okay, back to the presentation. Where's my, oops, okay. So, I had Kibana. What else is in Kibana? Yeah, that's basically what I said before. If you download the slides, it's basically as a reference for you. Won't repeat it. Yeah, no results found. Typically, you need to expand your time range. Yeah, graphic visualize and dashboards. So, in the context of SUSE Manager, give you a couple of examples how we did it in SUSE Manager to connect this. So initially, so what is SUSE Manager? Probably most of you have heard about this. Is a lifecycle management and patch tool for if you have many Linux systems, you can have a central. And it has quite some components. It has Apache, Tomcat, a Postgres database, a Java application stack, and might come as a surprise, Salt. Just kidding. You know this already. But all these write logs somewhere. So it's an awful amount of logs. And how it got started, just a short story. So earlier this year, we had a patch for SUSE Manager. There was an error. We fixed it. We tested it. Engineering tested it. Our automated test suite passed. We provided it to QA for manual testing. They were fine with it. Everything green. So we released it to the customer. And support calls came in. Massive. Because at the customer side, it broke. And we were baffled. We were so, oh, passed all of our tests, even the manual test. How could that be? And actually, it was a more long-term thing. But we could have found it by analyzing the logs. Because in the logs, the service which broke down already spitted out error messages long before it actually came to errors in the UI or in client management. This was for us the trigger saying, oh, we need to do something. And getting now SUSE Manager configured to write logs to Logstash is a bit ugly. So this is a typical configuration for Apache. Here, for example, this is the error log. So it writes to the local file and via netcat writes to the Logstash server at port 9001. This is a Tomcat configuration, so I need to edit log4j properties with a Logstash appender, add these logs. So getting SUSE Manager configured to write it logs to Logstash is pretty intrusive and pretty ugly and not reliable. So at the end, this approach turned out to be a quite bad idea. Oops, what are we going to do now? Java is also ugly. So luckily, there's another tool from Elastic, and this is called Beats. Beats is a new tool written in Go, which is a front end to Elastic. And the nice thing about Beats, formerly called Logstash Forwarder, that it just sits in the machine and reads directly from the file system. So it reads the log files which are written to the file system. I don't have to reconfigure Apache, I don't have to reconfigure Tomcat, I don't have to reconfigure my Java application stack. I just run FileBeats, and it monitors the log files as soon as one of the tools writes a new log file. FileBeats sees it and forwards it to Logstash. Very fast, very small, and very simple to configure. You have seen in the previous example, I splitted it out. So I opened the Logstash port for this type of log, and for that type of log, and for that type. So I have many, many open ports. The nice thing about FileBeats is it already wraps the log line into JSON and adds some metadata saying, hey, this log line I read from this log file. So then when this data comes to Logstash, it is already kind of formatted, and I already know, okay, this line is coming from this file. And then I can use this pattern for it. So all I need is on the system, so here in this example, to the manager, install the FileBeat package, have one FileBeat YAML configuration file, and the various little daemons which look for the log files are called prospectors. So here's a typical, so I say, okay, watch for the access log from Apache, and coding usually UTF-8. Input type is for FileBeat. It's a log file. There just expect text lines there, and the document type is what gets added to the metadata, transferred to Logstash, and I can analyze this as I did with a type in Logstash. And I can use all my work I did for the filtercon, for the patterns. It's reusable here. But it's much easier because it's a single port for Logstash where all this data gets in. Very, very nice, very, very good. And it works. It's very reliable. I didn't lose any logs compared to the previous setup. So highly recommended. Yes, we do have packages for this. So this is in the open source build service. I hope all of you know about the build service. If you don't, shame on you. Go to build.opensuse.org, have a look. This is where all the packages get built and where everyone can build packages. And this is then structured into projects. And the project where these files are is security:login. And for example, this is then the package for Elasticsearch. And Elasticsearch is currently the first package which builds in a clean way, in the sense that actually the Elasticsearch Java code is compiled during build. I've also packaged Logstash and Kibana, but this is just a repackage of the binary distribution. So this is not how we want to distribute and how we want to build packages, but from a practical perspective, it's useful and usable now. But you have to trust upstream that there's no malicious code in the binary distribution. But in the Java world, you do a lot of binary downloads. Yeah. Okay, so what are we going to do with this? I do intend to provide complete, correctly built packages. I do intend to kind of do sample queries, especially for our tools like SUSE Manager. I know that the storage guys, Eric is here, are interested in this. The cloud guys approached me already for SUSE OpenStack Cloud. So we want to give best practices, and maybe we can find out how to package these Kibana queries or Kibana visualizations, so that we can provide you packages which are pre-configured for the context, be it to the manager, to the storage, or to the OpenStack Cloud. Document best practices. This presentation is actually the first start. This is the first kind of documentation. What we did in the SUSE Manager team already is, so we started with automated tests long ago. So as soon as a developer changes source code, checks it in, this triggers a package build. Part of a package build is a unit test, a functional test, and when these passed, out of the collection of packages, we build a new SUSE Manager instance and run the complete test suite on it. This creates log files, many of them. And we already write them to our internal Logstash instance. And we are just in the process of trying to find good visualizations. Especially in the story I told before of the package update, which went out, passed all our QA tests, but the error was in the log. This is the intention here, to find these things much, much earlier. Then we have something called Hack Week at SUSE. This is 2 times a year, a week where every engineer can do whatever he wants in terms of coding, in terms of hacking. And what I did in the last Hack Week was I used this to analyze support configs. Support configs is a big tarball of all the settings from a customer server, but this is a valuable data source for us. It has all the installed packages, so we can analyze, okay, from all the support configs we have, what kind of packages are there? It has hardware data, and of course it has all the log information. And when bugs hit engineering, we usually ask for this support config, and then it is a manual process to analyze these things. And the goal here is to automate this. That we have somehow a tool, I have sample code, which unpacks these support configs, feeds them all to Logstash, Elasticsearch, and then runs a couple of automated queries to find the hot spots the unusual things which probably are the cause for the error. So this is an ongoing kind of research project. And if there is enough interest in the market, maybe we productize it as part of SUSE application stack. But this actually depends on you, if this has enough interest. Yeah, that's it from me. Any more questions? Yes.
Yeah, Klaus, one question about the UI. At the moment, it's basically per user, right? So when you change things, you can't say I log out and then someone else logs in and gets different dashboards.
As far as I know, there is no user management in Kibana. Yeah, and the default setup is also there is no access control to Elasticsearch. You can do this, but I didn't.
And you could then package it up at least so that someone gets a fully pre-configured dashboard.
That's the intention. Yeah. I don't know how this is done. I know that Kibana uses Elasticsearch to store the visualizations, to store the dashboards, and that's probably where we could hook in and grab these and feed it to the Elasticsearch at the customer side. Yeah. Other questions? If anyone wants a slide, if you have a USB stick, I'm happy to share this with you. All right? Thanks for your attention and